Hello viewers, in today's class we are going to discuss one important problem related to three-dimensional geometry, right? And here we have to solve this problem, that is find the vector equation of the line passing through the point with position vector I cap minus 2j cap plus 5k cap and perpendicular to the plane vector r dot 2I cap minus 3j cap minus k cap is equal to 0, right? So in this problem we have to find the equation of a line which passes through this point, right? So here the point is given and the coordinates of the point are 1 minus 2 comma 5, right? So this is the point through which this line passes through, right? So here this is the line whose equation is to be determined, and this line is perpendicular to this plane. So let us draw the plane like this, right? So here we have the plane. Let us say this plane is pi, right? So the vector equation can be written as here r can be written as xi plus yj cap plus zk cap, right? So if we take the dot product of these two vectors, the Cartesian equation is 2x minus 3y and minus z is equal to 0, right? So this is the Cartesian equation of this plane pi, right? And this line is perpendicular to this plane pi, right? And we have to find the equation of this line, and this line is passing through this point 1 comma here the coefficient of I cap is 1, so 1 minus 2 and 5. So now we know that the equation of a line which passes through some point, say x1, y1, z1, and having direction ratios as a, b, and c, the equation of a line is written as x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? So first of all we'll find out the Cartesian equation of this line L, and then we'll convert it into vector form, right? So the equation of a line which passes through some point x1, y1, z1 having direction ratios a, b, and c, right? So now let us draw the perpendicular vector or the normal vector to this plane, right? So this is the normal vector to this plane pi, right? So now since the line is perpendicular to this plane pi, so this normal vector which is perpendicular to this plane pi is parallel to the given line, right? Okay, so now this line L is parallel to this normal vector, and from vector algebra we know that if two lines are or two vectors are parallel, then their direction ratios are either equal or proportional. Now the direction ratios of the normal vector can be obtained from the Cartesian equation of the plane, right? And here we see that the coefficients of x, y, and z always gives the direction ratios of the normal vector to the plane, right? So the drs of the normal vector are given by the coefficients of x, y, and z. So the drs are 2, minus 3, and minus 1, right? Now the line is parallel to the normal vector n, right? So the direction ratios of this line may be taken as 2, minus 3, and minus 1, right? So here A, B, C can be replaced by 2, minus 3 and minus 1, and the line passes through x1, y1, z1. So the point 1, minus 2 and 5 can be taken as x1, y1, z1. So now the equation of this line L can be written as x minus x1. So x1 is 1 and a is 2. Then we have y minus y1. y1 is minus 2. So here it becomes positive 2 and b is minus 3, right? And z minus z1. So z1 is 5. So here we have z minus 5 over c, and c is minus 1, right? So a can be taken as 2, b is minus 3, c is minus 1. So this is the Cartesian equation of this line L, right? So this line L is perpendicular to this plane pi. So this line is parallel to this normal vector, right? Hence the direction ratios of the line can be taken as the direction ratios of the normal vector, right? So now let us convert this Cartesian equation into vector form. So now we know that the vector form of a line is given by vector r equal to vector a plus lambda times b, right? So this is the vector equation of any line passing through some point a, right, whose position vector is given by vector a, right? So the vector a can be taken as this point, that is 1, minus 2 and 5. So now we can write vector a as I cap, 1 I cap, minus 2j cap, then plus 5k cap, right? And here lambda is some scalar, and this vector b is given by the vector which is formed by the direction ratios of the line, right? So the direction ratios are 2, minus 3 and minus 1, right? So vector b can be formed from the these numbers, that is 2, minus 3 and minus 1. So here we have 2i cap, minus 3j cap and minus k cap, right? So viewers, this is the vector form of this line L, right? So this vector a represents the point through which this line L passes through, and this vector b is given by the direction ratios of the line, right? Or in other words, we can also say that this vector b is a vector which is parallel to this line L, right? So b is the vector which is parallel to this line L. So the components of this vector b represents the direction ratios of the given line.